Alright, we're live. How's everyone doing today? Yeah, I might be like 4 minutes late to my own stream, but you know, that's the average college experience. You go to the wrong side of campus and then all of a sudden you don't want to walk anymore and it's like, damn. So yeah, regardless of that, I'm still here. I'm still ready to write some code. Yeah. So last night I did a lot of thinking, and I thought about what the best way to rewrite mem-to-reg is, and I reviewed all the algorithms and all the books, and by all the books I mean the singular book, and I think I have a pretty clear idea of what that algorithm looks like relative to what I want it to do. So yeah, that's not a really good time, but to get to that point we need to add a dominator tree analysis. And when the time comes, I'll explain what that is. But first priority, as always, is going to be leetcode. So let's get this booted up. Yeah, okay. Yeah, let's give this a look. Compare version numbers, okay. Okay, so revisions separated by dots. Integer conversion, ignoring leading zeros. Okay, sure. So the annoying part here will probably just be like the actual conversion. Yeah, the rest of it shouldn't be that bad. We can just, I guess, append zeros as necessary. So it should be fine. Yeah. So let's make a vector of int. Yeah, this is a vector of int, and this is version 1's values, I guess. I don't know. And then I guess we could do like version 1.substr. It's like we can do like a int cur equals 0. This is cur to version. Actually, no. We need to find all the dots. This plus split string by delimiter. We could just, yeah, we could look at this one, I guess. We could even just like, we can do like a shitty for loop, I guess. Int I equals 0, I is less than version 1.size, and then I plus plus. So if I is not a, yeah, if I, it's like version 1 I, so we wanna keep going until we find a dot. So if it's a dot, then we wanna push back. So we want s2i of version 1.substr from cur to I guess. Yeah, that seems about right. And then cur, we wanna add, or cur is, why am I pushing back? do we set this to I plus 1, actually. And then we need to do it one more time here to handle the stuff after the dot. And then we can... But we don't have I anymore, so we need version 1 size, I guess. Let's just make sure this compiles real quick. Yeah, that's expected. Bruh. Okay, cool. So it compiles. Cool. And then we can do something similar here and just make it once instead of having to store it a second time. We do this, and then here we do version 2.size. Okay, so version 2, if that's a dot, then yeah, okay, so if version 1, I guess we need so we need cur, and then we need num versions, I guess. And then we can steal this S to I thing from cur to I. Yeah, and then this should be fine. If it's equal, then should... Oh, that's my bookmarks. Whoops. Let's actually do like... Do I have caps lock on? Oh, I have caps lock on. Let's do less than... I guess we can even... So I guess like v1 val equals that, and then v2 val equals this one. Let's change that. And then if v1 val is greater than v2 val, then return 1. If it's less than, we return -1. Otherwise, we keep going. So then we reset cur, and then num versions plus, I guess. We also need one more comparison here, which is num versions is num versions greater than or equal to whatchamacallit, version 1 dot values dot size. Because then we have, then version 2 has more. Then we can do this whole mess here. We can do a ternary operator with v1 val. Versions greater than or equal version 1 values dot size. Let's do less than here, and then we can clean up the ternary operator. Otherwise, it's just 0. Yeah, we're making a little bit of a mess here, and then Okay. Versions is less than version 1 values dot size. Or it's like while. So then we can then just steal a lot of this even. I know there's probably a less ugly way to do this, but so it goes. Actually, no, I can't think of it off the top of my head. Yeah, so we can. I want this, and then this should be 0. And then there we go. This should run. Oh, I'm missing a return 0. What am I missing? 17. Oh. There we go. I'm missing a semicolon. Okay. Should be good. No, it's not. Okay. Okay, what's going wrong here? Oh, I'm missing the cleanup stuff as well. Yeah, we're just gonna duplicate code. I don't really care anymore. Yeah, we're just gonna do this. This is really ugly, but it is what it is. This doesn't exist because yeah, we should do that. Methinks. Oh, we don't have I anymore. Okay, nice. This is logically sound. This is not very pretty, but you know, it runs. Like, it'll do. This problem does not need to be 41 lines. Let's see what the pretty solution is. Oh, we just parse. Okay, yeah. Okay. Sure. Okay. Cool. Okay. So that's the leetcode. Yeah. Let's get the rest of this party started. Let me check something real quick. Okay. Sure. So, mem to reg. This pass I've been trying to write, but low-key it's been a little bit difficult. And that's mostly because I've had little idea of like what's actually happening under the hood. So I did a lot of reading, and I think I have like a rough idea of what I need to implement now. I just need to like get around to doing it. So yeah, the prerequisite to this though is creating a dominator tree. So there's like two main algorithms that people use. There's like a really fast one by two people. They made like a paper about it. It got pretty famous. The one I'm gonna use is like the other standard one, the fixed point algorithm, because well, it's easier. Yeah, let me find where I am. Okay. Okay, cool. So we need to make an analysis real quick. I'm in the wrong directory completely. Okay. So, yeah, let's make dominator tree dot cp and then dot h. Yeah. So then these are, what is one? There we go. Yeah, so these are analysis passes. So we need, okay. So how did I structure new passes? Let's see. Pragma wants to include the pass stuff. Make a middle end namespace, and then we want dominator tree. It's public. Analysis pass. Did I get rid of analysis pass as like a literal thing? No, it definitely exists. Okay. So this has run, I guess. And then I think these we can keep the same. Yeah, I don't think we need that much more here. We do need to register, we need to like figure out how to register this pass here though. How did I structure this? Void override. Wow, I can't type. Oh my god, I can't type. Okay. Yeah, so this pass itself is kind of boring at least. Or at least like the header for the pass. Okay. We need private fields. I need like a dominator tree node. Actually, I don't need that. I just need two maps, I think. I wrote this on the side. So we have an ordered map from, we need to import some stuff, I think. Unless this already is imported. So we need mir basic block putter to another one of these. And then I guess this is predecessors. Hi, I'm currently working on a custom backend with LLVM for custom ISA, but finding this AutoGlen official LLVM is not easy. Yeah, I kind of ran into that issue myself as well. I think like the first, I guess like there's two parts to this answer. The first is that like, I feel like you kind of just have to deal with the, I guess, whatever state of the documentation that exists within LLVM, specifically the Doxygen. For what it's worth, I think it's surely been pretty reasonably indexed into ChatGPT by now. So I think like, unironically, I don't think that's a terrible place to look in terms of like actually looking into it. Second, if you haven't looked at the or it's like part 1.5, if you haven't looked at like LLVM's like work in progress backend tutorial. I think that might also be useful. I haven't like looked too closely at it, but it might have a couple of nice tidbits here and there. And then second, I think so like that covers this sort of like LLVM proper stuff. And then in terms of like the theory stuff, I think that kind of just comes from various books and papers. And that's kind of on you to look up. I imagine that like if you're trying to do things that have like already been done before to some degree, just for like pedagogical purposes, I think like some of the big textbooks are probably good resources to look at. But I can't really give too many other recommendations beyond that. You'll just have to like look up various different papers and books, unfortunately. What's good, Frothy? Good to see you today in chat. I am implementing a dominator tree analysis pass because I need that for fee insertion and also just like SSA construction in general. Okay, so we have predecessors mapping, and then we have this should be a vector of our basic block. This should not be processors. What am I doing here? Successors, I guess. So one of these lets us traverse back up the tree, which is predecessors. We can just follow that like a chain. And then successors will have to, I guess this allows us to traverse the other way, either through DFS or BFS, hopefully. Both are important at some point, but hopefully this will make things a little bit more manageable. And then we need to like actually create the dominator tree. Unless the resources rather than copying textbooks, or rather than textbooks, like tutorials, are mostly copy pasting existing stuff and changing variable names without explaining logic. Yeah, I think that roughly makes sense. I think LLVM's tutorial is probably not bad though. I think it was it this one? No, it wasn't. There was something else. Yeah, I imagine this is probably useful to some degree. It was this one. Let me turn on Dark Reader so you don't get full blinded. Yeah, I imagine this is like pretty work in progress from what I heard, but I imagine that it would have a lot of the useful stuff you're looking for. A lot of this is like talking more about like the front end pile, but the relevant stuff is like the all this middle end stuff, which like explains, I guess, LLVM's IR proper, and then this back end pile, which is like actually the relevant part. Yeah. If you want this URL, you can just like pause the stream, I guess, and just like get it real quick. You could just look up like LLVM backend for CPU 0. Yeah, this should be pretty reasonable. I haven't like gone through this or this one either, so no guarantees on anything, but I imagine that's a reasonable place to start. What was it doing? Oh, right, yeah, this is good. In terms of the implementing LLVM versions of this project is very old. Yeah, I guess that makes sense, but also, like, surely most of the concepts carry over to some degree, right? But if you want like anything that's like specifically LLVM 20, that might be a little bit hard to come by. Or 21, I think. I don't remember what they're on anymore. Okay. Yeah, so let's add just like, yeah, this is fine, I think. This should be fine. I should real quick figure out how to add this to mem to reg. But first I need to build this out a little bit more. we make a pass, and then this takes in dominator tree. We can get rid of this. This should be dominator tree run. Okay. Yeah, this will be interesting at least. Yeah, we'll figure that out as we go. Also, my hair is not cooperating with me, so apologies if I'm messing with it a lot. Okay, so this should compile now at least. But what we want to do is we need to implement like the link passes thing, or register passes thing, or register analyses. Yeah. So let's go down here. Should be transform pass register analyses. What's good, Skittles? Good to see you. Actually, maybe maybe I shouldn't make this a vector, because that'd be a little bit annoying to search. Can I make this a something that isn't a vector, actually? Started applying to a ton of internships. Nice, good stuff. Yeah, vectors are great, but I also need to I care more about searching than insertion here, so, or at least I'll do more searching than I'll do of insertion. So that leads me to think maybe like a set or something makes sense here. Yeah, I mean, I guess I could try that real quick. How do I call this again? It's just in Pass Manager, right? Yeah. Actually, no, this is fine. This should be fine. Yeah, this data structure seems a little bit troll for this. Yeah, okay. So let's do... Can I do an unordered set, even? Let's try that. This should work, hopefully. But that means I do need to like rewrite a couple of things here and there, which is like fair enough, but like still. Okay, so analyses is an unordered set. Unordered set of unique putter of analysis pass. So we need to... This can stay a vector, actually, I think. But this one... No, this is fine. Let's paste over that. So we want that. Can paste over that. Nothing changes here because we haven't needed to use that yet. Yeah, I think that's all of them. Okay, no format changes, so we're good to go. Yeah, so now we can look up in like a more reasonable way instead of running a linear search every time through the array or through the vector. This would be in here, I guess. Oh wait, no, this doesn't work. Wait. We need to check if it has the pass. There's not really a good way of just like checking that, I guess, other than, well, literally dynamic casting every single pass there is. So maybe we find a better way to represent this. Okay, we might have to keep a second set as well. A second set as well. Sorry about that. Yeah, okay. How do we do this? What's even the best way to do this? So we have our analysis set here. We might just have to do a linear search over, which is like really funny. Okay, we're just gonna do that until performance becomes a concern, and then we will clean it up as we see fit. But until then, I guess, yeah, I did not think this through in any regard. So we're gonna undo, do boop, boop. And then let's undo those. Okay. So modified memtredge, and then we add those. Okay. Cool. Yeah, this is gonna be like really slow code, for better or for worse. Actually, factually, just for worse. Hopefully I can do it in a better way. Hopefully I can figure out a better way to do this. Okay, so for each pass in here, yeah, we're just gonna dynamic cast and pray. Hopefully it's not that slow, but it might end up quite slow. So we want dominator, or what's DT? To dominator tree putter, and then we want, where's pass.get, and then if dt, then so we want, yeah, we wanna save this somewhere in here as well. So we want dominator tree putter dt, I guess. Oh, we need to include this. Whoops. That. Life is good. It's not actually good because we're searching through an array, but you know. dt equals dt. Can I do this? No. I need this dt. We don't want transform pass. We want mem to reg. I need to steal this. Did you rock the Dominance Frontier? I believe I did. Yeah, I like looked it up in ChatGPT yesterday, and it eventually ended up making some degree of sense to me. I'll do my best to try and explain it live. Yeah, we'll see how that ends up going, but it should make for some pretty funny content regardless. Yeah. So let's paste that in. Oh, that is an ugly function signature if I've ever seen one. There we go. That looks a little bit less ugly. Okay, so this works in theory. Then so this is still a null putter. Then we want to make a new dominator tree. Yeah, maybe I should like. Yeah, maybe I should like make this into some sort of a macro, but whatever. I'm just gonna fold this by hand, I guess, call it a day. I don't think we need anything in these, right? Yeah, this should be fine. So then this d equals dt dot get once again, and then Ulysses. I'm gonna push back, and I'm gonna move dt into there. Okay. So yeah, in is this all visible? It looks like it's all visible. Yeah. So just to like explain what this does now. So what we give it here in the function signature, this thing here is the is like the analyses vector in our pass manager, and then we look through that. If we find that we already have a dominator tree pass in the analyses, then we just register that one. And then if we don't find it, then we just make a new one and then we insert it. That's roughly what happens here. Yeah. So yeah, should be a good time. I think by construction this shouldn't include duplicates, but I don't think that'll be a problem, hopefully. If it ends up becoming a problem by some miracle, it'll be really funny, but until that day happens, I'm not that scared, at least. Yeah, okay. So let's just make real quick. And then just to test this, so if we run this on our if test, it is absolutely gonna crash. But if we run it on something that doesn't have branches, I think it should run. Yeah, okay. So it runs cleanly. We haven't made changes to it yet though, so if we run the if test, it should crash. And should as in like it's probably a good thing that it crashes because it would not generate correct code. So yeah, that's That's like the basic scaffolding. Let's commit something real quick. Initial dominator tree scaffolding, and then what did I change in here? Oh yeah, register analyses. Okay. Register dominator tree pass in mem to reg. Okay, so that's a good start. So now that all the boring boilerplate is out of the way, we get to finally start writing this pass. So let me just like, do I try the harder algorithm or do I just do the fixed point one for now? Linger target. Does this have like the pseudocode anywhere? Oh, the scan is really scuffed. Yeah, I'm gonna figure that out in the future. For now, dominator tree fixed point algorithm. Or maybe it's in here? Oh yeah, it's this one. Okay. So dominator at each node is itself. And then is there a dominator tree? Oh, let's just give straight up dominators, I guess. So start node is just itself. And then all other nodes, we set all nodes as the dominators. And then, sure, okay. Is there a dominator tree algorithm somewhere? There's gotta be one that's like not that difficult. I swear there was like an article that had one. Oh, it might be in this. Yeah. Is it this one? It might be this one. Yeah, it might be this one. Okay. Maybe I could just look at that paper even? History. Reverse post order iterative. Okay. Yeah, this seems like the least miserable one to implement for now, at least. So, yeah. If there's a way to like go from the dominator list to, oh wait, here's just like the straight up. It's the tree version. Yeah. Okay. Yeah. If there's a way to just like go from a dominator mapping to just the tree, I might do that even. That might be fun to mess around with. Finger. That's pretty funny. Okay. Yeah, Yeah, so then I'll just skim this paper real quick. This also has the dominance frontier algorithm, which will be useful as well. Okay, sure. Sure, okay. Alright. Let's start up here, I guess, because I know why it's necessary, but I don't understand the algorithm, so... Okay. You can pose the problem as a set of data flow equations, solve them that way. This is the properties. Simple insights. And carefully engineer your data structure to more efficient implementation. Okay. Okay, so each node gets a dominator set and dominates B if, yeah, so this is just the definition of a dominator. If every path to node B must go through node N, then N dominates B. And B also dominates itself, as an example. Immediate dominator is just like the furthest down dominator, I guess. And that's nice because then we can just like iterate back up through the tree if we turn this into a tree form. So we can even like do a little bit of renaming real quick. Actually, no. Let's keep this predecessors. Okay. This relation that's compiling can be done as a for data flow. Yeah, this is like the iterative algorithm, the one that seemed easy enough. I want a tree though, so I'm not doing this. Tough luck. Yeah. Yeah, so we set the dominators of each node to just be every node. And then at each iteration, we do this. I'm... How do I read this? Anyway, let me try to read this again. So it's the union of all. It's the union of all of the dominators of the node's predecessors. Or no. It's the... Yeah. Daily C++ check-in, welcome. I get to do a little bit of reading for a bit, unfortunately, but... union versus join. Is that the... Set theory, union, intersection. Which one is which again? Okay, union is the U-shaped one, okay. Still undergrad? Yes, I guess I'm technically both undergrad and master's student right now, but I feel very much like an undergrad right now, so. Okay, so this is intersection. Yeah, so we AND all of the dominators of the node's predecessors, and then we add that to the dominator list. Okay, this makes sense now. I don't miss it. Did my master's in physics? Ooh, fun stuff. 3 years in C++ dev role. Good stuff. Yeah, honestly that seems low key where I want to end up to some degree. So you have a lot of respect from me. Any tips for reading coding textbooks? I've been reading one on OS and it's a little confusing. I think the big thing is just to take your time. Yeah, there's a lot of material, and it's not really a race. You're going through it so you can learn. So make sure you take your time on things. It doesn't matter if you like only get through like 2 or 3 pages, as long as you're just like reading with intent, I guess. Like if you're just like skimming through this, not really like engaging with the material at all, I guess like if you go through an entire textbook and like you haven't had an instance where you're like, I don't know what's going on, and like you literally stop and just like take a second just to like figure that out, then you're reading wrong. So yeah, it's not a bad thing to like be confused sometimes. Just like keep at it. Maybe do a bit of Googling here and there, maybe a little bit of ChatGPT to like fill in some gaps. Make sure the stuff makes sense to you, and then like move on, I guess. You'll get yourself a role. Thank you. Yeah, hopefully if I keep this up for long enough, I will have done enough residual work to have a cracked resume, I guess. Not quite there yet, but give me a year. I'll be cooking. Okay. Yeah, iterative algorithm is this one. Yeah, I guess this makes sense. This is literally just this thing here. Yeah, so we just keep doing this. We just keep doing this, removing nodes until the algorithm reaches a fixed point, I guess. So yeah, that algorithm seems simple enough. Okay. Correct initialization is important. The algorithm must initialize each to include all the nodes, or must exclude uninitialized sets. Okay, sure. I don't see that off the top of my head. It makes the most sense to me as all the nodes. So I think I'm going to leave that at that, because this is not the algorithm I care about. I care about the one that they describe further down here. Okay. Equations for dominator from a distributive data flow framework. Yeah, that makes sense. So like the changes kind of like percolate down, I guess. Yeah, it'll discover eventually and halt. Maximum fixed point solution is identical to the mean overall path solution. Equations for a dominator are simple enough that they form rapid framework. Whatever that means. Iterative algorithm that traverses reverse poster. Sure. That roughly makes sense to me. This is an example of that. Impractically slow. Huge. Okay. Bit vector DOM sets 900 times slower than Lingor Tarjan. 0 times wasted. Yeah, that roughly makes sense. increased memory requirements. That's huge. Okay. Memory efficient data structure. I think this is where they... Is this where they mention the dominator tree? Yes. Okay. There we are. Yeah. Consistent order. Elements agreed. Nodes copying the resulting set. Yeah. Okay. Yeah. This roughly makes sense. Like, dominance is transitive. At least if I understood that correctly. It's like if A dominates node B and B dominates C, then A necessarily dominates C as well. That logically seems to make sense to me. So that means we can store dominators in a tree format where the parent of each node is its immediate dominator. So like I guess the closest / like furthest down dominator from that node. Yeah. How does this handle loops actually? I'm curious. Okay. So let's do like the standard little loop. So let's do this. We can do this. This goes back up here. Or actually no, let's split this off into two. As an example. And we straight line that down. Let's add this one up here. Let's number these. Or let's give these letters A, B, C, D, E, and then F. Okay. So the nodes that dominate A is just A. Yeah, let's use this color, I guess. B is dominated by just A. Because just intuitively, E, or A and B, because yeah, there's no guarantee we have to go through E, but E has a guarantee that it has to go through B, so dominator here is A and then B. Dominator C is just A and B as well. D is also A and B. Or also itself. C. And then D. E's dominators is not C or D because they can control flow can come from the other path, but E necessarily has to come from B or A. So the dominators of E are A, B, and E. And then F also would have to come from E, I guess. So A, B, and E, and then F. Okay, so then, oh boy. So then this tree looks like, so A is at the top. That makes sense. And then I think just B here. Right. Yeah. And then we have C, D, and E that all come from B. And then F comes from E, so okay. This roughly makes sense, at least at a glance. Yeah, okay. So the tree is just like the most immediate dominator at each. The most immediate, what was it called? absolute dominator, I think it was called. Dominator. Let's just look this up real quick. Immediate? Strict dominate. The immediate dominator is the lowest strict dominator. So that's just a node that dominates it. That is not the node itself. So, yeah. Okay. Yeah. So each node is a child of its immediate dominator in the CFG. Yeah, so intuitively we can understand this set, sort of. We can understand the dominator list, or dominator set at each node as the node itself, and then the node's immediate dominator, and then that node's immediate dominator, and then that node's immediate dominator. Yeah, so then we can build this little thing from that. And as you can see, if we start at each node, we can kind of just traverse our way back up the tree to get all of its dominators, which is really nice, and it'll be very useful later. Okay. Yeah, we create in that order. Yeah. Yeah, we can make a tree. Wow. Yeah. Yippee. Represent the dominator tree. Read the dom sets from the tree. Single array for the whole CFG indexed by node. For node B, we represent B's inclusion implicitly. The entry holds immediate dominator of B. And then, yeah, okay. So this just says we can walk up the tree, which, yeah, we very much can walk up the tree, which is really nice. Let's perform intersection by starting at the back of the DOM set and moving towards the front. This reverses the sense and termination condition. This is the one we want. Under the scheme, we move backwards through the list, comparing elements until they are the same. Okay. Okay. Two-finger algorithm. Okay, so I fear we might have found another way to describe a two-pointer. We found another way to describe a two-pointer algorithm, I think. It actually sucks at enjoy when training the AI on C++. Yeah. I feel like AI is really good for like front-end code just because like there's so much slop that's been pushed out. But like a lot of the actually quality low-level code, I think, is gated behind like some sort of a proprietary wall. And there's like some open source stuff, but like I also think that like C++ code just serves a lot of purposes. So like the training data is kind of like I guess it's kind of like an average of all of the different types of C++ you can write, which is very good for like an intro class, but if you want to do anything like remotely useful for C++, just because of the sheer number of things you can do with it, I think it is bound to be not amazing at it. JIT versus AOT compilers, I don't really have an opinion. I think they both have reasons to exist. When I first like learned about JIT compilers, I was like, this is stupid, why would you do that? And then I thought about it and was like, it's kind of the best of both worlds, so like I kind of get it. But also like, ahead of time is like canonical, it does what you need it to, so like, I also think it's fine. I'm just gonna grab a template, too lazy to make the UI? Yeah, that's fair enough actually. Yeah, if you're... Yeah, I don't even have any like qualification to add to that. Just straight up just steal something and call it a day. Okay. So what is this algorithm? ImGUI templates are based? Yeah. Honestly, any sort of template is based. The less work you can do, the better, low-key. Okay. So we make everything exist. Dominators of the wait. Is this the tree? This should make a tree. Okay, so what is this? Am I imagining this correctly? Post order numbers. Okay. Yeah, okay. So this is a tree. Year 4. Okay. 1. Wait, why is this 4 iterations? Loop connectedness, one greater than the example. Okay. Okay. So we start at 6. First iteration. The hell? Okay. What the hell? Sent UI in the server? Let's see. Oh, I see. Okay. Yeah. Yeah, that might be a little unfortunate. Yeah. Yeah, I'm not gonna lie, I don't have a lot of UI design experience. And I'm also just like not really familiar with the libraries, just like period. So yeah, you're unfortunately a little bit on your own for this, I think. So much reading to do. So what does this do? So we set the start node. And we do this until no changes. Pick one. Okay. So you pick a predecessor. And then we intersect them. What? Right. Oh, okay. So from this, I think we're just making a new set. A new item is the new set. Okay. Yeah, I mean, this algorithm seems simple enough. Oh, I see. Okay. So this just finds, given two nodes, find their, find, I guess, least common ancestor? Greatest common ancestor. Yeah, that's the term. Okay, cool. It's all coming back to me now. Okay. So we reverse post order. First process predecessor. For all other predecessors. If it's already calculated? Huh? Oh, I see. No, I don't see. This seems confusing to me. Oh, it's not undefined. Okay, all good, all good. Okay. So if we've calculated it, we just intersect the two. Oh, I see. And then, okay, yeah. This matters for like number related traversal order reasons. I see. We could probably number these as we go then as well. Yeah, because the predecessors of some node will always be less than that node. So we just keep doing that until the two are equal, and that means that we've reached a shared node. Or we've reached a common ancestor. Okay, so the predecessor for all other predecessors. If we've calculated it, then we intersect. And then, okay. Okay, this roughly makes sense to me. What is this guy's implementation of this as well? Yeah, okay. Yeah, okay, so we also need to... Yeah, we need to create this map as well. Just for numbering reasons. Yeah, and then intersect might be a useful algorithm to have here. Yeah, I guess that roughly makes sense. Okay. Alright, let's start implementing this. I think this should be pretty manageable. It's this one, this window. Let's close that out. Okay, let's get started. Okay. So real quick, just so I remember, I'll just have this up. Yeah, okay. Okay. So for each function, oh wait, we need another layer of mapping here. From function to map, I guess. Actually, that doesn't even matter, because each basic block is a unique pointer, so we can kind of just like glue them all together and call it a day. We have the entry basic block at each function, so I'm not that concerned. So P, get functions, and then for auto basic block in F dot get basic blocks. Okay. We can even just like iterate across it in this big loop here. Let's give this a try. So we need a temporary mapping of some sort. So we need ordered map from basic block putter. We don't need to include that here. So from that pointer to, I guess, in 64. So this is numberings. I guess, what is it called here? There is a specific word. So let me turn Dark Reader on, sorry about that. Where is this? Traverse order, I guess we will call it. Yeah, we'll just call this traverse order. I guess like traversal numberings. I know in his other article, I know he definitely includes it. So let's check. I know in his Lengar Tarjan explanation he has it. God damn it, where is it? Go to home. Let's put it in another. Dominators, and then it has to be. Am I just blind? Oh yeah, I am blind. Okay, found it. DFS tree, okay. So DFS order, I guess we could just call it. I think there was like an implementation here I could also draw from to some degree. Okay. Yeah, okay. So we also need a counter. And then should be uint 64t. So DFS order at BB. we want counter plus plus. U.get. Okay, perfect. And then we want, oh, we need a work list. We can't do it like this. Yeah, let's make a stack. So we want a vector of basic block putter work list. I think we will be reusing this work list as well, which is really funny. Yeah, so let's put this up here. Okay, so then work list dot push back. So we want f dot get entry block. That's a putter. What's wrong here? Stud vector. While is not empty. Okay. So DFS order at, we don't have that basic block iterator anymore. Instead we have back, and then I'm gonna pop back, and then TFS order at cur is counter plus plus, and then so for auto successor in cur dot cur arrow get successors. Oh, we also need to make sure that it's not in DFS order already. Yeah, okay. What is reverse post order traversal again? Let me just check this. Opposite of post order, okay. BCA. Okay, so that, sure, okay, cool. Cool. Does this visit duplicates by definition? Surely not, right? Am I tripping? What's good, gamer? Dup try. Welcome to the stream. Oh, I see. Okay. Cool. So we want topological sort, which, god damn it. God damn it. Oh, this is really annoying. Is there a better way to do this? I suppose not. Okay. Well, we can probably do this in one pass then, right? We don't need like this DFS counter thing. Or like we still do, but it's a little bit less annoying. Okay, so we need counter. And then let's keep this here. Okay. Okay, I think we need, we might need to do some topo sort stuff. So we need an unordered map from... So we want this to T, this needs in degree. And then we should get this real quick. So we have that, and then we have successors, right? So we can just in degree at basic block. We can set this to the predecessor size, right? Surely, right? Like this seems way easier than like having to do it by hand. Okay. So we can do that, and then yeah, instead of having to iterate through successors. Okay, so make a work list, we add the entry block, so while it's not empty, get rid of this. I think Memtoreg, the way I currently have it implemented, I think we also have a little bit of oh no, this is not topo sorted at all. Okay. Versus post order, so no is added after its descendants have been visited. Yeah, okay, sure. Okay. Okay, so then for each successor in, so here we need like do something. For your successor, incur its successors. Then in degree at. Does this work? No, this doesn't work. You can't do Khan's algorithm for this. Right, because loops. Yeah, we can't. This will not work. Okay. That makes a little bit of a mess of things, but that's fine. Let's get rid of this real quick. Oh, this is just straight up post-order traversal. I see. I might just be dense. Okay. So we number by post-order traversal. What does this look like for a graph again? Okay, I guess this sort of makes sense. Yeah, okay. And what was the algorithm here? We can just make like some map, right? Is that kind of what we need? What is this actual implementation? Okay, I see. Then, okay, this is the pile. What is post order DFS? Where does this come from? Ah, here it is. Ah, I see. Okay. Yeah, Okay, so we just visit the Trojan first, which sure, fair enough. Okay. Cool. Okay, sounds good. Let's actually implement this shit now. Yeah, let's use a work list for this, I think. No, we shouldn't. Let's throw in just like some post-order traversal function here. What is this? What should this give us? This should give us a vector, I think. Vector of grr. You just give it DFS order, I guess, or something. Okay. So it's crazy how like the hardest part about this for me is just like figuring out how to post order traverse, which is like low-key something I should know, I feel like. So we could just like take the work list, right? How did our homies do this? So we don't want to, maybe we don't want a work list here. So we want each. We'll figure this out as we go. Okay, so. We need the numberings anyways, unfortunately. Which sucks, but... and then we want a vector of... that should be... post order. We can just do that, I guess. So we'll do that. And then maybe I'll just throw lambda in here, I guess. That's like post order traverse. Oh wait, no. We should make this separate. Okay. So we want number blocks. press like post order number, number, post order. And let's give it post order and then traversal order. And then let's give it let's give it a block. So we want f dot get entry block. So we'll want that, I think. How long have you been programming? I've written real code since like my freshman year of college, but I have like some experience before that point at least. It's not a lot, but it's at least something. Okay, let's actually just like this. Yeah, we can do this. Let's give it a helper as well. So we want basic block. This is entry. And we give it a vector. Basic block putters, this will be a reference, universal order, and then we want whatever this is so confusing already. Numberings, I guess. Man, this looks hard. Yeah, it's a lot of stuff, but we can break it all down slowly, at least. Traversal numbers, I guess. What's wrong here? Undeclared? Oh, I renamed it. Numbers. Let's make this a little bit shorter. Numbers. Yeah, we can do that, and then I'm so washed. How do I even write this? Let's make a counter, and then it's like a backtracking algorithm, I guess. This sucks. This really freaking sucks. Okay. So what do we do here? What do we do here? So we want to visit the node. So we want to visit the node's children, and then we add the node. I'm gonna essentially keep a. You should keep a counter. More compiler content? Yep. We can just do one more pass through with a counter and make it a little bit prettier. No, we should do it at the same time. Aww. Does it compile anything yet? Not quite yet. Currently we go from C down to the optimizer language. I need to generate a backend eventually, but I'll figure that out at some point. Okay, so let's recurse post order. So we want node. We can just steal everything in here. I want to keep the buffers, so I'm going to backspace that. Let's paste. Node. There's BB. Let's shorten some of these names. TO. TN, I guess. And then one other thing we need here is the uint64 reference. Counter. Okay. Keep it up, your grind is inspiring, thank you. Hearing that is honestly one of like the big reasons that I keep streaming, so I appreciate the sentiment substantially. And hopefully at least one other person in the world decides to work on some personal project daily. Because of whatever the hell I'm doing here. Okay. So we need to... So for auto successor in bb.getSuccessors, so successor is, I guess if the numbers have it. If we've generated a numbering for that, that means we visited it already. And then we can visit that. So tn.contains successor. Then yeah. So if it contains that, then if it has that, then, or if it doesn't have that, that's what we want. Then successor, or we can recurse post order. We pass in successor, TO, TN, counter. We can also get rid of these braces. After that, then yeah, if it doesn't have any successors, then like yippee. Ooh, wait a second. If we have a loop, this will run infinitely, I think. How do we do this? Maybe we set the current one to 0 first. So it at least exists. Okay, so let's tian at okay. Tian at bb is null putter. Okay, that equals 0. No, because it's a number. That really sucks. Okay. No, but it's fine. We can just do this. So this way we prevent loops. This is kind of an ugly solution, but I mean, it works, so it goes. And then tian at basic block. Equals counter plus plus. We postfix increment. Yeah, okay. I think this should do what we want. Yeah, let's let's throw an IO stream real quick and then print at each iteration. We can do this, and then we can visiting. Oh, this is not going to be helpful, huh? It just occurred to me. Yeah, let's do this. Yeah, the numbering for this is going to be a little bit stupid. Because... Because we're doing this to assign the numbers. So this will just vomit out like basic block 1 through n. I guess we could do something here. Let's just paste this. Let's do entering basic block counter +1. Let's do that, and then we can exiting basic block counter. Yeah, we can just do it like this, I think. This might be the least awful way to do it, but yeah, we can... This is a little bit stupid. Yeah, so this will be... What do we give this? Let's give it entry, traversal, order, traversal, numbers, and then counter. That. How do we do this again? Oh god. I'm like really struggling here. What made you switch to Windows over Hyperland? My laptop still runs Hyperland, but I'm on Windows here because I have a raging Valorant addiction that needs to be addressed in some way. I definitely use a counter here. I have to use a counter, I think, surely. I do some like insane numbering stuff in 2-string. Counter. Oh wait, here it is. Okay. Counter, and then that doesn't. We don't do that anymore. I had a version where I had like a counter that I passed around. Oh, I know why. Yeah, okay. Can I just do that? Or do I just do this and call it a day? Okay, perfect. Anyway, what do I want to do here? Yeah, we print now, so this runs that. Okay. So let's give this a try. This should print a bunch of shit. It does not print a bunch of shit. That's not supposed to happen. Why doesn't it print a bunch of shit? Pass manager. Rerun if invalid. I think we define it in here, right? Yeah. If we run the pass, then can do that, I guess. I can't believe I never set that, which is really funny. Yeah, valid is false by default. Yeah, so we get the analyses, we run if invalid. It should vomit out a bunch of stuff. It doesn't vomit out a bunch of stuff. That's not ideal. Do we even... We do create the dominator tree, right? Surely. Yeah, it's here, right? And then it's a null pointer by default, so it should be fine. Did I even call register analyses? No, we add pass, yeah. So we do that, and then we push the pass back. Okay, let's see if this even gets run. Okay. Creating dominator tree. Stream. Let's build. Alright. Okay, so we create the dominator tree, but it's never run. So we registered it. We do that much. That's for sure. Oh yeah, we need to run it. Pass manager.run. Do we run it? We should run it, right? Running. This better mate. This better run. It doesn't. Okay. Am I like running the wrong thing in here? The task manager? No, it doesn't. It doesn't run. Interesting. Do I need to like call super? Is that what I'm missing? Or something? Or maybe it's just not registered. Just to be clear, I do add the, okay, yeah. C++ subclass constructor. Okay, so it should be called for me, so like, what the helly? Oh, virtual. Is this what I'm missing? No, it shouldn't be. What? Do I need to like pass this in as like a reference? Or like... No, it's a unique pointer, so that should be fine. We can't copy it. We have to move it. What's going wrong then? Maybe in memthread's thing? Oh, wait a second. Wait, what? Should be fine. What is going wrong? Stood. Why isn't this working? So we made DT. So we registered analyses. So that definitely happened. Yeah, so this is all running properly. And I see no stack variables, which implies this is doing what we want it to. But but what do now? P get analyses. What happens if I make these mutable again? We should get a lot of ugly output, in theory. No, okay. Let's unconst that actually. 'Cause I like that safety guarantee. Let's rebuild again. Okay, so we do run okay, that narrowly helps me. But why aren't we running? That means it's empty? P get analyses. What? I'm quite confused why it's not running. Okay, let's throw this into ChatGPT maybe. Why isn't this running? We're definitely. Actually, we should just print out the size of this. Okay, so it is empty. Okay. We know that now. Okay, so let's steal that. Let's move it into here. Okay, so it is just 0. And it's called 3 times. Why is it called 3 times? Why is it called 3 times? Good analyses. Oh fuck, is it added each time? Or fail added each time? What? Oh my god, wait a second. Wait, I think I figured it out. Why is some analysis past putter? Oh wait, no, this is fine, but then I think we're storing the wrong thing in required analyses. Oh yeah, okay, I know exactly where we're going wrong now. This. We should get rid of DT. We want required analyses, I think, is the one. It is a, yeah, so we have that. Shouldn't need that. We want required analyses, which I also realized I named wrong, but various reasons. Let's change that real quick. Let's rename that real quick. I think I get it now. We're not putting it in the right place, basically. Yeah, so we want this get analyses, I think. Yeah, we want this dot push back. I'm gonna push back. Pass dot get. Where's DT, I guess? No, we should pass dot get, right? Oh, because this is const. God damn it. Oh. Oh, come on. Protected. Oh. God damn it. Okay. So now I think we can just acquire, yeah, we can just directly do this now. Okay. Well, okay. Can I guess I could probably make like a template sort of thing for this, but okay, what do we give this now? That's like bool has dt equals false. We can do that, and then we can even just break here. If we don't have dt, then now we can do that. And then dt dot get. Okay. Oh, fucking hell. Okay, we figured that little shenanigans out. Okay. Okay, cool. Cool. Okay. Yeah, so we can even get rid of our prints now. Do you rewatch your streams to go through your thought process, or is this mainly for accountability? Yeah, it's mostly for accountability. Although I do I've been trying to go back through them and add timestamps, both as like quality control and yeah, both in terms of like quality control and in terms of like adding timestamps, I guess. But I don't really like go back through my thought process too much though. This is fine. What did I change here? Yeah, okay, that makes sense. We don't need that here. I'm doing something similar for accountability. Nice, good stuff. Okay, these are the only ones that should have changes. Let's add some of these real quick. Minor. Oh yeah, let me just check if there's any other formatting changes I need. It doesn't look like I need it. Maybe I should also keep DT as well. It just occurred to me. But that seems a little bit duplicative. Yeah, I'll figure out a better way to generalize this next time. For now, this is kind of good for now. Let's make this protected. Let's see what's changing these real quick. It just, yeah, I'm actually just gonna do the duplicative storage thing. There's not that many passes anyway. I don't think it matters enough. Yeah, let's do that. We need to add back DT. And then need this. Do that. Yeah, okay. What's wrong here? Oh wait, we need analyses and then required analyses. dt.get. Okay. Can get rid of IO stream. Okay. Okay, so now if we make, here, we should get really ugly output again. Hopefully. Make. Hey, there we go. Okay. We're running. Okay. Let's get rid of that. Okay. Let's rebuild real quick. And then real quick, make. Let's see what this looks like here. It's a little bit stupid, admittedly. Wait, these numbers are wrong. I see why they're wrong. Yeah, that will never make sense. This prefix number. So we can just do this. And then we will just get a really stupid counter that just goes up, which completely makes sense, but also like, bruh, you know. Yeah, we go 1 2 1 2 1 2 1 2 1 2 1 2 1 2 1 2. Yeah. Okay, so let's give it another. Let's give it the if test, or if small at least. This should still crash, but it runs all of these, which is nice. Okay. So then. Okay. Yeah, so this should have 4 basic blocks. HR, let's confirm. Yeah, so we have entry, we have this, and then we have the new return block, which, yeah, okay. So that does what we want to do. We just have to hope that it's kind of in the right order right now. I don't have a good way of testing that, unfortunately. So, yeah. Unfortunate, but we will figure that out. I want to keep IO stream still because I want to like make sure we can like print things. Yeah. Okay, so now that we have the numberings, yeah, we can do this. We can split screen again and go back to the DAM algorithm. So we're through this pile now. Okay, so we want pool change equals true, I guess. Or we can do false. We can do a do while. Actually, no, I lied. I hate that. Yeah, okay, so changed equals false. And then we just keep iterating, I guess. So for auto be in traversal order. So we want, oh, we want reverse post order. So we want auto header equals traversal order dot r begin. Can I do a reverse for each loop? Nah, okay, we're gonna use reverse iterators. So iter not equals traversal order dot r end iter. Do I have plus plus? Yeah. I can do that. Predecessor and so I guess like auto cur hitter, we can do that. We can even hitter what is this? Anyway. What is traversal order again? Traversal order is basic blocks. Okay. How do we do this? Okay, let's get this chat GPT out of the way. What type is this? Iterator type, okay. How do I even use this? Oh, I can use ranges. That's cool. What is this? Okay, sure. What is reverse iterator? Yeah, fuck this. We're just gonna use no, I don't want to use indices. Let's use ranges. Let's use a range. Anything but using normal things. So we want what is the backwards range? I just tried to use a tiling window manager shortcut. I'm cooked. C++, range, reverse, iterate. What does this do? I think there's an example in here, right? Yeah, here it is. Ranges, reverse, view, reverse, traversal, order. This will take traversal order. That's pretty funny. Ranges. Okay, well, we figured that out, at least. In auto basic block, in reverse traversal order. That's so funny. Maybe I should put this further up as well. Okay, well, sure. Let's do that. Okay. So we have the algorithm. Reverse traversal order. This is so funny to me. I don't know why. I'm definitely gonna like take some time to rename as well when the time comes. So we want Except start node. Oh, this is fine actually. We can get the predecessors finally. Holy. I forgot I can use that as a short name. That's nice. I can do that as well, which is really funny. Here's predecessor. New item. Okay. So we want this at 0, I guess? What type is this? Okay, yeah, that seems about right. I might have hit the wrong bind. bind? I might have just misinput. That's really awkward. Alright, this is fine. Do that, and then if preds dot size equals 0, where it's empty, and continue, I guess. So you can do this, and then idom equals res. Where's our results? What's our result type again? Predecessors. We might need to do a little bit of renaming. No, it should be fine actually. Contains pred, then idom equals LCA of idom and I guess P versus pred. We can do that, and then we can make LCA. So we want mir basic block putter get LCA. I guess like we can just make this LCA. Get LCA. Find LCA. Okay. We should give it the silly thing. We could also just throw a lambda in here, to be honest. I might just do that. Actually, I kind of like having this separate, but no, let's make this a lambda. Lambda. This takes in basic block putter. Block 1, our basic block putter B2. I think we need to throw this further down somewhere. Probably here. Yes. While B1 not equals B2, then B1 is less than B2, or no, if traversal numbers at B1 is less than traversal numbers at B2. Actually, yeah, this makes sense. And we want B1 equals yeah, let's actually rename. We don't want predecessors here. This is confusing. Immediate dominators. Dominator tree. Is it reasonable to call this like immediate post dominators as well? It's the thing. I'd like to call it something different. Z post dominates N if all paths starting at N must go through Z. Okay. What is the opposite of I think I called it something here. Yeah, I think immediate dominators is the interesting one, and then topological sort, not quite. It's because topological sort doesn't work with loops, and I want it to work with loops. So I think the accurate term would just be reverse post-order traversal. So it's like, it's close to topo sort, but not quite. I guess we'll just call this reverse dominator graph. There has to be a better explanation. Okay, let's ask ChatGPT. Assume a dominator tree. The parent of a node is the immediate dominator. What are the children of a node called? Dominatees. Okay. Dominatees. That looks so stupid, but what are they called though? Yeah, let's just do that. Let's immediate dominated. Let's do that. Let's just call it immediate dominated. Yeah, because I'm scared of like some sort of a name collision somewhere. That would be a little bit annoying. So traversal numbers, we want dominators at B1. Else we want the same thing but with B2. And we want return B1, I guess. Should have that. Okay. Cool. So we have that. And then in the paper, if it's changed, then we, I guess if it's changed, then we can do the thing. Let's do that, and then I also need to set the start node, it looks like. Yeah, this makes sense, and then do that, and then if idom is not the same as immediate dominators at BB. And this is fine because that'll just insert a null pointer, I think. And then we can just immediate dominators at BB. Actually, we can just set it as a null pointer, right? This is fine because we kind of need all of them. Do we need them? Let's do that, I guess. This is now idom, and then changed is now a true, and then this runs until we're done. Okay, this is quite interesting. Okay. So we have that, and then we also need to what else do we need? We need to set the other graph, I guess. Auto pair in immediate dominators. We want dominated at pair dot second. Yes. Dot push back pair dot first. Okay, perfect. What is wrong? Insert. Yes. What is this again? It's a map to vector. Okay, this should be working. It should be default initialized at least. Oh, this needs to be a putter. Whoops. Okay, and now we can can do a little bit of printing. Let's just make a quick little map as well. Actually, we already have a map. What am I doing? Alright, so pair in traversal order for numbers. We want print. So the second is the number, the first is the block. So pair dot second. So how do we want to represent this arrow? Yeah, we can do this, I guess. And then immediate dominators. And we put in pair dot first. But we need this to be pretty as well. So we want traversal numbers at that. Hopefully this works. I really hope this works. What's good, Janine? Good timing, because I think I've correctly implemented this algorithm. I hope I have. We'll find out very quickly if I have. Okay. This works still. Let's... Okay. So... does this make sense to me? 3... Yeah, this makes sense. This control flow makes sense, but this graph is a little bit boring. If, I guess like, what do we call this? Let's make this dt.c. Let's just steal another test from here. I think this might, yeah, let's do this. So if cond, and then, yeah, this should, this is so boring. This, all these control flow graphs are not particularly interesting. Cond, we can just like keep nesting this. Else we want we can just do it. We can even just like steal the else if real quick. That might be more reasonable. So we can do that. Return 5. Let me just indent this to be readable. So N64T 0. So that if val is greater than 150, turn 0, I guess. If val is less than 50, then let's res equals, let's do like 909 or something. I don't know. I don't know what I'm doing here. So dt.c. Hopefully this is a valid program. It'd be really funny if it wasn't. Okay, well it's not a valid program. That's disconcerting. Oh, we don't have greater thans yet. Whoops. Val. Else if. Whereas, let's just do this. Yeah, I sure as hell am building the boat as we... Okay, so this is not what we wanted to see. Yeah. Okay, let's make HR. Okay, let's draw this out. Let's draw out the control flow graph, what this should look like. So you have entry, and then so then we have if one or true one, else that's a funny face as well. Else, then we have more branches. F1. If so we have true one or T2, and then we have F2. Okay, so then so T1 and T2 all go straight to the return block. F2 goes to a continue block first. So cont. And then all of these point to return. So 1, 2, 3, 4, 5, 6, 7. 7 basic blocks is correct. So what is the immediate dominator of all of these? So yeah, we should be able to just write this out. So the immediate dominator of this return is the entry. Immediate dominator of this cont should be F1. F2 should be F1. T2 should be... Oh, right, no. Cont should be F2. F2 should be F1. T2 should be F1. Okay, let's rewrite this a little bit so it's a little bit more interesting here. Res equals 5. Make. Okay. Okay, so we've changed the way this is wired now. So let's erase this arrow. Let's undo things instead. Let's erase this arrow now. T2 should now point to... What brush size do I have? 5? 2? 2 looks right. T2 now goes to cont. Yeah, okay. One, 2, 3, 4, 5, 6, 7, 8, 9. Where did 9 come from? 1, 2, 3, 4, 5, 6, 7. What? Oh, I see. I generated this very naively. So we have entry, if t, this dangling block that goes nowhere. Okay, we need to redraw a lot of this, it appears. Okay, let's start this over. Let's start this completely over. Will this read? I hope this reads. Okay, so we have entry. And then this branches to... What? Are these both if t's? That seems not what we want, I think. Okay, wait, okay, a little bit of a side tangent, 1 second. Why is this generating if t's? Did I like mispaste something? This should be in here. HR to MR? AST to HR. Okay. This should be if F. This will break tests, I think. No, this shouldn't break tests. We don't test for it yet. Okay. Make HR. Okay. Okay, this is way easier to follow now. Thank fuck. Okay. So this line. So if t, and then we have, we'll just make t1 and then f1. So if t goes just straight to return, so let's throw this at the bottom here. We have this random block here, which is just the go-to if cont. So this big continuation. C1. Let's go straight down here, and then we also have C2, I believe, which also goes there. So we just have like ghost block. We can just point that here. Right? Well, that should be deleted at least, I think. Supposedly. But the math's not mathing. Okay, so we have this go-to. The false will have a go-to in it. This has T2 and F2. Yeah, okay. This makes how many again? 2, 3, 4, 5, 6, 7, 8. 8 blocks. 1, 2, 3, 4, 5, 6, 7, 8. Okay, we don't have this ghost block, which is good. So this goes to cont 1. Or so cont 2, I guess. So this goes straight down. And the false block goes straight down as well. Yeah, okay. Okay, we have like interesting control flow now, which is nice. So let's just write all the dominators. Returns dominator would have to be entry. C1 would be C2. C2 would be F1. F2 would be F1. T2 would be F1. F1 would be entry. And then 1, 2, 3, 4, 5, 6. Okay. And then T1 would be entry. Entry would be none. So then this dominator tree, based on this, so we have entry, and this has T1, F1, and return. And then T2, F2, and C2 all come from F1. And C2. And then so 1, 2, 3, 4, 5, 6, 7, and then C1 comes from C2. So if it wasn't obvious, this is very different from what we have here drawn out. So something has gone terribly wrong. Yeah, we need to debug something somewhere. Let's do this real quick. Fix incorrect false label name. Okay. I've been streaming since 7:30, so 8, 9, 10. Oh, it's been 3 hours. Okay. Well, let's throw another hour at this, I guess. I want to get this done. It'd be very cool if I could get this done. Okay. Alright. Let me go on a quick bathroom break real quick, and that'll give me a second to think as well. So yeah, I'll be right back. Please don't burn down the house while I'm away. Alright, I'm back. Give the camera a second to wake up. Take a sip of water. Okay. Let's see. What do we do here? So let's see if we're even like iterating here. that. Okay, well it ran once, which doesn't sound very correct to me. Okay. There was like an initial condition that I neglected, right? Start node is start node. Okay. Let's try that. So let me reorder things a little bit. So we want f dot get entry block. Do that. Okay, so for all nodes that aren't the start node, so if let's make this b equals f get entry block. If we have an error, we'll get an error, I guess. Okay, well, we now have it set to itself, which is wonderful, huge, incredible almost. So that's progress. And most importantly, it didn't crash, so. Where did we go wrong? For each node in the reverse traversal order, we skip if it's the entry node. So we get the first here. Oh, that might be it. Right? No, because no, that should be fine. If dominator says that, then maybe if we just what if we just set it to itself? Here, actually. Do this, I guess. Can you just I can make this a null footer for now. So this is if it's dom equals null putter, then we set it to pred, otherwise it's the LCA, right? What's wrong here? What do you mean this is not compatible? Okay. So why is this not working? Oh. Right, this doesn't work. So this should be our basic block putter. So if it exists, then yeah, so if it's not a null pointer, then we can put it to something, otherwise we just set it to the thing. So if this is not a null pointer, okay, this should work now. Make. Well, it's still not working. Let's see. Why isn't this working? Let's try making again. Okay, so we're just not finding any changes. What is wrong? Okay, so we just don't have predecessors to things, which is really strange. Because I feel like we literally wire this up. Right? We wired up like here. Yeah, we literally do this here. Can I do this? Why don't they have predecessors? The fuck? Okay, wait, this is a problem even just outside the scope of what I'm doing right now. Okay, let's try and figure that one out real quick. Let's turn off passes. Okay, so that builds properly. Do your best? Yeah, working on it. I think I got this though. This might be an until midnight stream. This might be a 5-hour long stream. First time seeing a channel without any Indian is crazy work, but yeah, I guess I'm here. Still tapping away. Okay, let's do a little bit more printing here. Then res. So we want creds, and then I'll be doing ML stuff. Good luck. Thank you. Good luck to you as well. ML stuff is way beyond my pay grade, so yeah, you have my respect for that. So we want new line, and then we want visitor dot, or we want basic block IDs at. Yeah, we don't care about successors right now. We literally just only care about predecessors, I think. Wait, no, this makes no sense. Wait, no. I'm tripping. We get successors, so we know successors exist. So why don't predecessors exist? The helly? So at pred. String at this. I want to ask very specifically into compilers. What do you think of Linux and kernels? I think Linux and kernels are quite cool. I just haven't learned enough about them. I found compilers are cool because I feel like they combine knowledge of like a lot of different domains of CS, like programming languages and architecture, and then just like general software engineering principles. It like combines everything into this one crazy field that does a lot of things. And I also just find the whole idea of like a program that makes other programs run faster just like really magical. And I guess that is part of what I want to continue here. Okay, so this should... Okay, so we do have predecessors, so I'm not tripping. That seems not ideal. What the fuck? Predecessor, this is 5. Hey, wait, what? How did, wait, what? So that's -1, I think. -1. Ah, that's entry. Okay. Why the fuck do 2 blocks come from entry? Something seems a little off here. Oh, I lied. I know why both come. Okay, yeah, sure. Okay. This goes to 12. 4 and 5 have this predecessor, and this goes to 12. Just as predecessor. This goes to 7 and 8. They both have 5. This is 9. 9 has 7 and 8 in theory, yep. And that goes to 10. Yeah, okay. So predecessors are correct. We have predecessors. So what's wrong? What's wrong here? Did I implement get predecessors wrong? This would be in here. Let's do this again. Let's get predecessors. And this should still print correctly. Yeah, okay. Yeah, okay. Sure. So, we literally have predecessors. Why is this not doing what we want it to? I guess why aren't these changing? The helly? I'm getting pinged. 1 second. Okay, sure. Okay. Yeah, of course. Okay. Why is this not working? Oh, I need to turn opt back on. So we have iteration. We have singular iteration. So we're not even going here. Is that the reference that was fucking it up? No, it's not. What is reverse traversal order? Do I even change traversal order? Oh, you've got to be kidding me. Oh my god, I actually bought it out. We need to actually assemble this. Ah. Okay. I think we figured it out now. That is like the most bot. That is like the most bot way I could have messed this up, to be honest. But this better work now. Okay, this does things now. Okay, wait, holy shit. Okay. Okay, so we can't actually determine which one is which, but one of these should have 3 predecessors plus itself. One of them should have 3, and one of them should have 1. So 7 has 4, or 4 have 7, 3 have 6, and 1 has 3. Okay, I think we did it correctly. Holy shit. Okay. Okay, we figured it out. Only took like a little bit of botting out to figure out, but we finally did it. Okay. We're so up. Okay, cool. Alright. Let's grab one of the examples from here, actually, I think. If that's even possible. I don't think I have a good way to. Yeah, I can't recreate the specific examples that are interesting to me, but yeah. Yeah, I think we implemented it correctly. Holy shit. Yeah, that's like one really big step now. We just need to like add an interface to it now, I think. Is there another graph we can look at? Yeah, this one might be good. Yeah, we can draw this out like this as well. Alright, so let me illustrate this with a test. Okay, so we have okay, so we have this. How do I even create this? Res, then so this branches off into 2. So this should, yeah, this is just gonna be like really ugly code, but trust me here. So if res, then else, we want something. Res, then we want another if. Res, then return res. This is like really stupid code, but trust me on this one. Else if res, then something else return res. Yeah, so I guess this is the graph I'm looking at. Yeah. So 0 nodes at the top. 5 is this, or I guess like inside here, true, then we go to here, which return res, and then this, is the else inside. This should just go to the fall through, I think. Oh, this is gonna be a fucking mess. Okay. This is fine. We can just do it like this even. Okay, this is more complex. Make HR. Let's give this a try now. All right. So we have entry, and then we have return. These are inevitable. So if that's true, we can go to if t and if f. So just name these simply. Okay, so if t is just the go-to. So this is cont. Just make the C as an example. And then T1. This should be cont 1, right? Yeah, cont 1. So if T1 and cont 1, T1 is just straight to return. If cont 1 is just go to cont, I guess. Wait, what? Wait, this code looks so strange. Wait, what? Okay. So this is just cont. C1 should go to cont. And now we go back up to this false. And then, okay. This goes to T2 and F1, which we don't have yet. So we can make these a thing. T2 and F1. Jesus, this control flow is quite messy. This goes to cont 2, which... So F1 goes straight to return. T2 goes to fucking cont 2, which goes straight to... Jesus Christ. Cont 2 goes straight to cont. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we have 10. Perfect. Okay. Alright, okay, cool. So we can infer that this is 9 off the rip, I guess. Entry is 9. So 5 nodes are dominated by it. Return is strictly dominated by it, so I guess let's just entry. C is dominated by entry. C2 is dominated by T2. T2 is dominated by F. F1 is dominated by F. F is dominated by entry. And then T1 is dominated by T. T is dominated by entry. Or I guess more precisely, when I say dominated, I guess immediately dominated by. C1 is immediately dominated by T. This is all of them. 1, 2, 3, 4, 5, 6, 7, 8, 9. And the entry is, I guess, entry. in this example. Okay. Alright, so then there's 1, 2, 3, 4, 5 that are dominated by entry, or immediately dominated. So 1, 2, 3, 4, 5. There is 1, 2 by T2, or by T, and then 1, 2 by F. So there should be 2 pairs somewhere. 4s, and then the 2 8s. And then just one random one left over. And this is the 6, I believe. Okay, I think this means we did it correctly, which is really good stuff. So yeah. Just for fun, let's try and number these properly. This is 9. Yeah, so entry has to be 9. Ret is probably 0, because that's the final block. Maybe I could have just like printed the graph, but you know. So 0, 9. There's 2 8s. 7 is dominated by 8. One of the ones dominated by 9. Wait. So it's 2, 4, and so one's dominated by 4. So it's probably, and then 4 is dominated by 9. So it's either of these. It's probably this, right? So this is 1. This is 4. What else is dominated by 4? 3 is this. So then 2 should be dominated by what? Wait. What? Okay, wait, so maybe this is 4, and then there should just be like a straight chain somewhere. The one random one, I think. 4. 4 is not the random one. 6 is the random one. Yeah, so it'd be like this. So this is 5. This is 6. 6 is dominated by 8. Okay, this is 8, and then 8 is by 9. So then this is also 7. Okay, so then that narrows it down a little. So this is that side. So T is, this one's 5, right? No. 2 of them are dominated by, no, that's 5. So 4. Yeah, so this is 4. And then this is like 2 and then 3, I guess? Oh wait, no. I'm missing 1. 1's dominated by 4, and then 3 is dominated by 4. Okay, so this is 1, this is 3, and then this is 2. Okay, we've reconstructed the graph. And this is good news for me because this means my shit was correct. So, yippee. So all we need to do now is we need to just like make a reasonable interface for this. Yeah. So what do we need? in this we want basic block putter, we want get idom, so it's not too long. So we want mr basic block putter bb, I guess. And then const vector vector of basic block putter should be reference. This should be get idom nodes. What do we call this? Get dominies, I guess. Yeah, we can do this. It looks like dominoes, which is really funny, and that's making me hungry again. But yeah, we can figure that problem out once we get this implemented. This should be very short, very quick. Is it this one? Yeah. You should add super chats. Unfortunately, I haven't hit the number of views yet for that. So I have the subs, but I just don't have the views yet. Maybe in like half a year, I think I will have enough, but until then, it's a little shit out of luck. Yeah, let's just do that. Let's just do the long name. Is there another way to do this? What other useful interface things can we do? I think this guy's implementation had a couple. Yeah, so we have idom, we have dominates. Ooh, that's actually a very useful one. That might be useful. Reachable from entry. Size is interesting, not really. Yeah, let's do dominates and then idom. So idom, dominates, and then we can do like yeah, let's start with get idom, get dominies, and then we want like pool dominates. So we want a basic block putter. So we want A, and then that's like BB1, and then BB2. Yeah, that's a really interesting one. That's a good one. I think we can. What else do we need to do? Maybe I should just set the entry block to a no putter as well. I think. Actually, no, this should be fine. Okay. Alright. Let's implement these, I guess. Yeah, this is fine. What the fuck? Okay. So we want... Should these be static? No, these should not be static. Dominator... Tree... So let's start with this one. This one seems a little bit interesting at least. Will this formatting ever become pretty again? No? Okay. That's shitting the bed. Do this. Alright, the formatting's still borked. That does not bring me joy. What's wrong here? Oh, these are in the wrong place. So out here. There we go. So auto cur equals bb1, while cur not equals. So while this is not the same as so what do we want here? We want so it's not equal to immediate dominators at her. So in cur and return true if they're the same. Or actually, no, we want the other way around. This is BB2. So SB1 return true. And then we want cur equals immediate dominators at cur. And return false. Yeah, we can do it like this, I think. Just double check against this guy's implementation. Entry block, then return 1. So B, while it's not the entry block, yeah, we should just if this, equals bb1, then return true. Yeah, I didn't think of that case. That will save a lot of time. So if they're the same, return true, and then we go up, and yeah, okay, nice. So that makes sense. And we just have these two more to do. Let's get immediate dominator, return immediate dominators at BB. And then this one, return immediate dominated at BB as well. Okay. So I think that's everything here. Let's see if tests build. I hope they do. If they build, that's great. If they pass, it's even better. I forgot to get rid of print output. Yeah, okay. Yeah, this looks about right. Let's do that. Okay, it passes everything. That's good stuff. Okay. And let's commit this. Implement dominator tree analysis. Pass. Alright. Yeah, that's everything. Yeah, this was a solid 4-hour stream. If you've been here this whole time, thank you so much for being here. I'm honestly surprised that I'm surprised that there's anyone still here at all, to be honest. This has kind of just been me staring at a paper and then trying to implement the one algorithm from the paper. It was definitely a nice warm-up to reading these things, but yeah. Make sure you all like the stream and sub to my channel. It really helps get my content out to more people and really helps out with the algorithm. And while you're down there, make sure you join the Discord. It's linked in the description, and it's the best place to chat with me. Best place to chat with me outside of normal stream hours, and also chat with the broader community. You can also send messages there and tell me to read them on stream. And it also is the best place to get notified when I go live. Usually I go live when the LeetCode daily resets your local time. Sometimes it's a little bit off, like today. I pushed it back half an hour. That is the first place that I will announce that. And of course, you should connect with me on LinkedIn and add me on GitHub to stay up to date with what I've been working on. So yeah, I'm gonna go grab some food and then do a little bit of homework before I go to bed. Thank you all for being here. Take care, take it easy, and hope you have a wonderful rest of your night.